Now we will move to another and the last type, type 4. If given differential equation is homogeneous, then how to go for integrating factor? Question is, what is homogeneous function? Homogeneous function, that is the every term or sum of the indices of every term must be equal. So for example, x cube plus y cube into dx plus y cube dy equals to 0. So x cube, the power is 3, y cube power is 3 and y cube power is 3. All terms have same power, so such differential equation is called homogeneous differential equation. So in this case, the integrating factor is given by 1 upon mx plus ny, and provided that this denominator is non-zero. Now you can see the first term x square y, the sum of the indices is 3. Then x y square is also 3, x cube is 3 and x square y is also 3. So it is homogeneous differential equation, but before that we must show it is non-exact. So let's write m, which is x square y minus 2xy square. We have n including negative sign, so we have minus of x cube plus 3x square y. Let's check. Dou m by dou y is x square minus 4xy, whereas dou n by dou x is minus 3x square plus 6xy. You can easily see they are not equal. That's why dou m by dou y is not equals to dou n by dou x. It is non-exact. Therefore, we observe the type of differential equation. Since we have already noted that it is homogeneous, so let's check the combination x into m plus y into n. So let's multiply m with x. So we get x cube y minus 2x square y square plus n into y, which is negative x cube y plus 3x square y square. So cancellation of x cube y will happen, and this is minus 2 plus 3 times x square y square is 1 time x square y square, which is non-zero. That's why integrating factor is 1 upon m into x plus n into y, which is 1 upon x square y square. Now we multiply differential equation, given differential equation 1 by integrating factor to make it exact. So it becomes
x square y minus 2xy square upon x square y square. This is after multiplying by integrating factor mdx minus x cube minus 3x square y upon x square
dy equals to 0, and we claim that this is exact. Now let's simplify for the solution. So with this plus and minus sign at numerator, we will open the brackets. So first term becomes 1 by y by cancelling x square and y from numerator and denominator. Then we get minus 2 by x dx minus x cube is getting, x square is getting cancelled, so x upon y square we get in the second factor minus 3 upon y dy equals to 0. So we have new m and new n. How to solve this differential equation which is exact? So we integrate m with respect to x. So this is 1 by y minus 2 by x dx. So 1 by y is constant with respect to x, that's why integral is x upon y, whereas integral of 1 by x is log x plus some c1. Now any term which is free from x in n is integrated secondly with respect to y. So first term contains x upon y square, so it contains x, so we will not take it. But second term, which is minus of minus 3 by y, which is plus 3 by y, is of our use. So it will come as 3 by y dy. So 3 is constant, 1 by y is integrated as log y plus c2. So this is equation 2 and this is equation 3. So solution is addition of equation 2 and 3. So we get x upon y minus 2 log x plus 3 log y equals to some c. Further, it can be written as x by y cube, and minus 2 log x can be written as minus of log of x square equal to c. And lastly, this is x upon y plus log of y cube upon x square equals to c. So this is the final form of the. So this method is useful when given differential equation is homogeneous. One more example on this. So here, now in this example, we will check first whether it is exact or non-exact. So writing example in standard form, we get xy plus y square dx, and taking minus sign inside, we get plus, and getting x inside, we get x square minus xy dy equals to 0. So we have to check first whether it is exact or non-exact. So here new m is xy plus y square, whereas n is x square minus xy. So let's check dou m upon dou y, which is x plus 2y, and dou n by dou x is a 2x minus y. So we can clearly see these two partial derivatives are not equal. That's why the given differential equation is non-exact. So we have non-exactness. So how to check? So we have seen the 4 rules. Now you can see the collective power, which we call sum of the indices, is 2 for every term. That's why we can call this is as a homogeneous function. Therefore, by rule number 4, we find out x into m plus y into n. And if this is not 0, then 1 upon this quantity is our integrating factor. So x into m becomes x square y plus xy square, plus y into n becomes plus x square y minus xy square. So xy square is getting cancelled, and we are getting 2 times x square y, which is non-zero. Therefore, integrating factor is 1 upon 2 x square y. So let's multiply given differential equation by integrating factor. So this is your equation 1. So let's multiply xy plus y square upon 2x square y dx plus x square minus xy upon 2x square y dy equals to 0, and we claim that this is exact. Now simplify further for integrals. So separating with numerator plus sign and cancelling the like terms, we get the first term as 1 upon 2x plus y upon 2x square dx plus this becomes 1 upon 2y minus 1 upon 2x dy is 0. Now this is new m and this is new n. Therefore, while solving exact differential equation, we need integral of mdx. So 1 by 2x plus y by 2x square dx gives you 1 by 2. Integral of 1 by x is log x plus y by 2, and integral of 1 by x square is minus 1 by x plus some c1, equation 2. Now we have terms in n free from x, which we call x free n with respect to y. So in n, only this term is free from x. So we'll take it only 1 by 2y dy, which is half of log of y plus some integral constant, say c2. So solution is nothing but addition of equation 2 and 3. So we get half of log of x minus y upon 2x plus half of log of y equals to, we will take for a moment constant as half of log of c. If we multiply throughout by 2, half is cancelled throughout. So we get log x into. So log x plus log y is log of x into y minus y by 2x equals to log of c or only c. C is arbitrary constant. We can put it anything. With this example, we saw how to make non-exact differential equation exact if we multiply it by suitable factor known as integrating factor. Thank you.